So in this video we're going to go over how to find the global extrema for a function if they exist. So for global extrema, it's different than what we did for the local min and the local max values in that we want to look at the function that we're working with over its entire domain. And what we're looking for is there a largest real number output that occurs, and is there a smallest real number output that occurs? And if we can find a largest output over the domain of the function, then we call that the global maximum or absolute maximum. And if we look over the domain of the function and we can identify that there is a smallest output value, that will then be our global or absolute minimum value. So we're looking for functions over their domain, and we're looking for, is there a largest output that occurs, or is there a smallest possible output that occurs? And if there is a largest or smallest, then those are going to be our global minimums and maximums. So first example, we're going to take a look at this function right here. We can tell it's a function because it passes the vertical line test. We want to identify the domain of this function because we want to look for our global min and max over the entire domain of the function. And we can see that this function truncates at an x value of -5 and truncates at an x on the right to the right at an x value of +5. So the domain of this function is x running over the closed interval from -5 to +5. And then this is going to generate some candidates for our global min and max values. So here at the endpoint, I'm going to go ahead and take a look at that. When we input the 5, the output looks to be a -3. When we look at the input of -5 over here, it looks like the function output is is 0. So here we have input 5, output -3. Here we have input -5, output 0. So if we have a closed interval, we always want to look at the endpoints of that closed interval if we're looking for a global extrema values. And then we also want to look at our local min and local max values because those are potential candidates to be the global maximum. And we see here that we have a local maximum located at an input of -2 and an output of, it looks like, 4. So we always want to, if we have a closed interval, we want to look at the endpoints of the closed interval. We also want to look at any relative extrema that the function has. And then if there is a largest value, that is going to be the global maximum. And in this case, it turns out that this local maximum is also the global maximum. This output of 4 is the largest output that occurs for this function. So we do have a global maximum, and the location of that maximum is at the ordered pair -2, 4, and the actual maximum is the output value, which is 4. And then this function also is going to turn out to have a global minimum, because there is a smallest output that occurs. And the two candidate spots are here and here, but clearly this one with an output of -3 is the smallest output that this particular function gives us. There's no part of this graph that extends below this point. So we have a global minimum at the location 5, -3, input 5, output -3, and the global max, or min, is the -3, or y equals -3. So the next example that we have, we want to scan this over. We want to look at what is the domain of this particular function. And here this is a GeoGebra graphic, so we know that we assume that there's arrows on the ends of the graph. And from that, we can see that there is a horizontal component to this arrow that points towards infinity in the x direction. And this arrow has a horizontal component pointing towards negative infinity. And I don't see any discontinuities in this particular graph. So I would say that the domain of this function, based on the graph that we're looking at, is x running from negative infinity to infinity. So we have an open interval, so we don't need to look at the endpoints of the domain because the domain doesn't have endpoints. So the next step is to identify the locations of the relative extrema, and we can see that we have a relative minimum here. When we input 0, the output is 0. We have a relative maximum here, which we would need to estimate. And then we have a relative minimum here at input 2, output 0. But it's going to turn out that I don't need to estimate this relative maximum because it's not the global maximum. And I know that it's not the global maximum because this arrow and this arrow both have components pointing towards infinity on the output axis. So I know that this function is giving me infinitely large outputs. There isn't a largest output that happens. The function continues to go up and up and up. So this local maximum can't be a global maximum because there's clearly outputs on the graph that are larger than that. However, it is also clear that these 2 points are both generating the smallest possible output that this graph gives me, because the graph is going up as we go towards infinity and towards negative infinity. The graph will not come back down and go below these 2 points. So we have a global minimum. So we have a global minimum of 0, or y equals 0. And that minimum value occurs in 2 spots. So we have 2 locations where the global minimum occurs. So global minimum of 0, which occurs at 0, 0 and 2, 0. So this was a case where I chose this particular example because there were two places where the global minimum occurs. Look at a final example. So the domain for this particular function, if we look at the fact that we have an arrow here and here, that tells us we're going to infinity relative to the input axis. The x values are going to infinity, and this arrow here with its horizontal component in that direction tells us that the x values are going off to negative infinity. So the domain of this function is negative infinity to infinity. So we have an open domain, open interval for the domain, so we don't need to look at the endpoints of the domain like we did in the first example, but we do need to identify the locations of the relative extrema. Those are your candidates for global extrema or global maximum values. But if we think about it, none of these are going to turn out to be global minimum or maximum values, because this function is going to infinity in the vertical direction, which means the outputs are getting infinitely large. And here, the arrow here indicates that the function outputs are going to negative infinity, so they're getting infinitely large but negative. So none of these values that are local minimums or maximums are going to represent global minimums or maximums. None of them will be the smallest output that you can get or the largest output that you can get. So it is okay for a function not to have a global min or a global max.